Okay, Assalamualaikum and hello everyone. So hari ini kita akan masuk chapter 10 which is wave properties of particle. So kalau chapter 10, pembahagian markahnya hanyalah 4% dan 3.3/80 markah di dalam PSPM2. Okay, so untuk pagi ni kita akan pergi kepada the first subtopic in chapter 10 which is the de Broglie wavelength. So kalau ejaan dia macam ni, de Broglie, but we pronounce as de Broglie. Okay. So it is de Broglie wavelength. Okay, the first one kita perlu tahu how state the wave particle duality. So we go to the first one. So in 1923, French physicist Louis de Broglie suggested that a particle, besides exhibiting particle properties such as having mass and momentum, may under different conditions exhibit wave properties such as having wavelength, showing diffraction and interference. So apa maksudnya? Okay, pada tahun 1923, physicist daripada Perancis which is Louis de Broglie, dia suggest yang partikel, for example electron and proton, sebab dia ialah partikel, exhibiting particle properties. So partikel memang akan ada particle properties seperti mempunyai mass dan momentum. May under different condition, dalam keadaan yang lain, partikel boleh ada wave properties seperti mempunyai wavelength, showing diffraction and interference. So itu yang de Broglie cuba suggest. Okay, dia kata particle is a particle. So kalau particle, dia akan ada mass, velocity and momentum. Okay, selain pada itu, keadaan yang lain juga, partikel boleh ada wave properties seperti ada wavelength and diffraction. Okay. So it is called a wave particle duality. What is mean by duality? Duality maksudnya dalam keadaan yang lain, particle is a particle dan dia juga boleh ada wave properties. So ada wave dan particle duality. Okay. The phenomenon where under certain circumstances a particle exhibit wave properties and other condition a wave exhibit a properties of a particle, but we cannot observe both aspect of its behavior simultaneously. So dia kata particle boleh ada wave properties dan wave boleh ada particle properties, tetapi kita tak boleh observe both at the same time. Okay, so apakah contoh yang kita dah belajar which is ada duality? So we have learned in chapter 9 that the light can be observed as a packet. So light can behave as a particle. So Einstein kata light is a photon. So photon ialah photoelectric effects and Compton effect. So in chapter 9 kita belajar yang light behave as a particle. But in chapter 8 kita belajar light behave as a wave. Sebab apa? Kita ada satu cahaya yang masuk dekat satu slit ataupun dua slit dan cahaya tersebut dia diffract ataupun bending of light. Okay, so cahaya tersebut exhibit as a wave in chapter 8 and in chapter 9 kita belajar photon. Okay, Planck kata cahaya dalam bentuk paket ataupun kuanta. So light is a duality. Okay, and evidence to show duality of a particle. So particle itself is a particle, but we can see a particle behave like a wave di dalam eksperimen electron diffraction, which is kita akan tengok dekat 10.2 Davison-Germer experiment. Okay, so that is the wave particle duality. Okay. And now we go to the next one, 10.1b. We need to use the de Broglie wavelength which is lambda equals to h over p. So what is de Broglie wavelength? Okay, in chapter 9 kita dah belajar photon energy E is equals to hc over lambda. And we know Einstein kata E is equals to mc square. Dan disebabkan momentum P is equals to mc, PE is equals to PC. Sebab kita just ubah dekat sini. E equals to mc square. So E is equals to M ialah kat sini kan, from here M is equals to P over C. P over C times C square, kita akan dapat E equals to PC. So this is E yang sama. Kita samakan equation kita, HF ataupun HC over lambda is equals to PC. So we can cancel the C, kita akan dapat H over lambda equals to P, tetapi dia ialah de Broglie wavelength. So we want to find the wavelength. So lambda is equals to H over P. So from this equation, the lambda is shown that properties of the wave, and the momentum it show the properties of the particle. So H ialah constant, Planck constant 6.63, exponent negative 34. P is the momentum. Okay, the unit momentum kgms -1. Then lambda is the wavelength. Unit for wavelength is meter, right? And you have to know electron mass is also constant. Okay, so this is the de Broglie wavelength equation yang kita perlu tahu, and it is given in your list of formula. Right. So itu sahaja untuk de Broglie wavelength. Next kita akan tengok kepada example.